Hello folks, we come back with the part 4 video of this exercise 13.2 and let's quickly get started with the things that we had started off. We had started with the derivatives. In the last exercise we did limits. Now in this part we had seen the ready reckoner and we had seen the first principle, then we had seen the algebra. So all this will be using in an assorted form in the questions to come. So let's take this question. They give us a function like this. Now define the function. So let's define this function as f of x. Let f of x be this function which is x raised to n minus a raised to n by x minus a. Now we can see it as a quotient, isn't it? So we'll be applying the quotient rule and getting the answer, but because we are beginners, right? So we'll make a substitution and let the numerator be u and let the denominator be v. So what will happen? You will get u dash, the derivative will be x raised to n minus a raised to n the whole derivative, which is like x raised to n's derivative minus a raised to n's derivative. This is a number, so it doesn't have a derivative. This is nx raised to n minus 1 by the very formula. And v, if we want to take the derivative, it's derivative of x minus a, which is derivative of x minus derivative of a, is a number, doesn't have a derivative. X means it's x raised to 1. So 1 into x raised to 1 minus 1, 0. Always remember x will have a derivative 1. Henceforth, I will be only telling that so that we are like kind of used to it. So therefore, f of x is actually u by v for us. So when we find out the derivative, it is the quotient rule which says v into u dash minus u into v dash by v square. And we have all this. We'll substitute. V for us is x minus a, u dash for us is n x raised to n minus 1. U for us is x raised to n minus a raised to n, and v dash for us is 1 that doesn't contribute, by v squared, which is x minus a the whole squared. So let's expand all this and see what happens. N x raised to n minus 1 and x raised to 1, a raised to m into a raised to n is a raised to m plus n. When it gets added up, n minus 1 plus 1 will make it n. Then minus na x raised to n minus 1 minus x raised to n plus a raised to n. Just check. By x minus a the whole squared. Right. So these are like terms. So maybe you can call it as n minus 1 times x raised to n minus na raised to n a x raised to n minus 1 plus a raised to n the whole of x minus a the whole squared. That's it. So that's about this problem. Then we are moving to the next problem, where also they give us, it's a question number 9, they ask us to find the derivative. Let me check if it's by any first principle. No, find the derivative is only told. So we will be finding the derivative by whatever way we want. For our convenience, we are calling it as let f of x be equal to 2x minus 3 by 4. So derivative of fx is derivative of each of these terms. How will that come? It is like derivative of 2x minus derivative of 3 by 4 is a number, it goes off. And this 2 means 2 will jump out and you have to find only the derivative of x. Now x raised to 1, I told you we will have the derivative as 1 always. So it's like 2 into 1, answer is 2. Now here also let's call this function as f of x. Let f of x be equal to 5x cube plus 3x minus 1 into x minus 1. This can be done in two ways. One is that you treat it as a product and you do it. Otherwise you can open up the bracket and solve it and do it. So I think we'll go for the solving. That is much better. This into this, this into this. So it is like 5x raised to 4. 5x cube into x will come as 5x raised to 4. Then minus 5x cube. Then let's take this. 3x squared minus 3x, then this minus x plus 1. Okay, so many, that's much better. It's better to take the derivative like this. So take the derivative of this entire term, minus 5x cube plus 3x squared minus 3, like terms are there. So minus 4x minus 3x minus 3x minus 4x plus 1. Yeah, only one like term. That's what I was wondering. We are taking the derivative of this. We are taking the derivative of individual terms. This is just because we are beginners, we are writing it like that. Later on, we'll develop huge speed and we can do all this really fast. This 5 comes out, and the derivative of 4x raised to 4 is 4x cube, nx raised to n minus 1. 5 comes out, derivative of x cube is 3x squared. Then 3 comes out, derivative of x squared is 2x. 4 comes out, derivative of x is 1, and 1 is a number, so derivative is 0. Finally, this is 20x cube minus 15x squared plus 6x minus 4. So those are the coefficients. That's it. So that's about this problem. We could have done it by product rule, but somehow product rule is a little more lengthier. This is a little more shorter, so we will do it like this. Then we have the third problem, that's also product. Either that you take it as a product, or because it is x raised to minus 3, you can take it as a quotient and you do it. Both ways it's fine. It's a good idea to take a product, right? The product is, in practice, work is lesser in product as compared to quotient. So maybe we'll take it up as a product. Let f of x be this function. What is that? X raised to minus 3 times 5 plus 3x. And because we are beginners, we are substituting that. Let u be x raised to minus 3 and v be 5 plus 3x. So because we know we will require the derivatives, we will right away find it. N x raised to n minus 1. N minus 1 minus 3 minus 1 minus 4. That's all. And here derivative of 5 plus derivative of 3x. 3 comes out. So 5 number no derivative. X derivative is 1 we know. So derivative is 3. Now the fx is becoming u into v. So f dash x will become u into v dash plus v into u dash. Now what is u? It is x raised to minus 3. What is v dash? It is 3. What is v? It is 5 plus 3x. And what is u dash? It is minus 3x raised to minus 4. So let's restructure and write this. It is 3 by x cube, and it is 3 by x raised to 4, 3x plus 5. If you want, you can equalize into x into x. So it will become 3x plus 9x plus 15. Yeah, that's totally optional. Otherwise you can leave if you want. 12x plus 15 by x raised to 4. You can take a 3 out, 4x plus 5 by x raised to 4. That's all what you say, part of solving. Like you want to simplify it and you want to do it. Minus 3 times 2x plus 5 minus 3 times 2x plus 5 by x raised to 4. Oh, serious errors. Wait. Sorry. Serious errors. This minus I have overlooked, right? So here actually this minus is going to come, right? Let's restructure. Why do wrong things? So it's like 3x by x raised to 4 minus 9x minus 15, right? So this will be minus 6x. Minus 6x minus 15 by x raised to 4. Yeah, now you can have a minus 3 out. So you have 2x plus 5 by x raised to 4. That's it. Yeah. Next problem also is on the same lines. If you want, we can do it by quotient, or we can take product rule and do it. I will always vouch for product rule. Work is much simpler. So let's call this function as f of x. Let f of x be x raised to 5 times 3 minus 6 x raised to minus 9. And let u be x raised to 5 and v be 3 minus 6 x raised to minus 9. So what is u dash? It is 5x raised to 4. What is v dash? It is 3 minus 6x raised to minus 9, the whole derivative, which means derivative of 3 minus derivative of 6x raised to minus 9, the whole derivative. Derivative of 3, because it's a number, is 0, and minus 6 is already there. N x raised to n minus 1, minus 10. So 9 6 are 54 x raised to minus 10. That's it. Right? Once we have it ready, it's easy for us. Therefore, now f of x is u into v, which means f dash x is going to be u into v dash plus v into u dash. U for us is x raised to 5 and v dash is 54 times x raised to minus 10. And v for us, it is 3 minus x raised to minus 9 and u dash for us it is 5x raised to 4. Now we cannot leave things like this because these are all solvable and simplifiable. So we'll have to do all that. Let's see, we'll do it gradually. 54x raised to 5 by x raised to 10 actually. Let's see what happens here. 5x raised to 4 in the numerator, 3 minus 6 by x raised to 9. This is the meaning. Now we'll obviously have to equalize this. So what will come? This will go 54 by x raised to 5. Then, I don't know whether you saw 3 common. So 5 3s are 50. X raised to 4. 3 is common. So it is like x raised to 9 minus 2 and x raised to 9. We can have it solved. This is x raised to 5. Now denominators are same. So 54 plus 15 x raised to 9 minus 30 whole by x raised to 5. These are like terms. So 15 x raised to 9 plus 24 by x raised to 5. I will have to check. 15 x raised to 9 plus 24 by x raised to 5. That's it. Right. That's how we solve it. Amongst this also, if you want, you can take a 3 common. There are other questions also, but I think it's no need to strangle it. We can have our next part and we can have problems in that in our next part video. Thank you.